Okay. Hello out there. Welcome back for another Solace Office Hours. My name is Aaron. I work for Solace. I'm happy to be joined by my colleague, Steve, to stream. There we go. Hey, Steve.
Hi, Aaron. How are you?
All right. I'm good. How are you doing today?
Good. I'm very well.
So it is noon on Wednesday, July 14th. Happy Wednesday, wherever you are. We're here for an hour. We're live on YouTube. We're live on LinkedIn and on Twitter. And we're here to answer your questions. Solace questions about event-driven architectures, questions about, I don't know, programming, software, you name it. Love and relationships. We'll take them all. Any kind of questions you have out there. So tell us where you're tuning in from. What time is it? What's the weather like over there? Hey, Gary. Hey, good to see you. How's it going? And Steve.
Hi, Gary.
Thanks for tuning in. I'm going to try to drive kind of two different screens here. Let's go ahead and share my desktop. There we go. All right, so as usual, we're going to be taking questions live on air. If you have a question, please put it in the chat. We'll try to keep an eye on that and answer them. They can be about Solace. They can be about Solace monitoring, about developing Solace applications, best practices, anything like that. You got a question out there. Gary, you're already online. I know you're out there. So, hey, if you have a question and you want to ask Steve and I, please do. We'll be happy to answer it. Any kind of, so here's upcoming events. Here's we're very meta right now. We're on our own live stream. Anything else coming up that we should mention? Right. The yes. Kafka Summit, right? Yeah, Steve, that's right. You reminded me just before. I actually pulled up the website here. So Kafka Summit, Solace has a couple speaking slots at this. This is Kafka Summit. The APAC one is in 2 weeks, July 27th, 28th. We're going to be, Phil, our illustrious leader, technology leader here in APAC, is going to be speaking. And yours truly, along with my very good colleague, Ari, we're going to be running some demos showing off the Kafka Solace integration. Let's see here, speakers. I think Phil is in here somewhere. There's Phil. We're going to be running a demo of the Kafka discovery, the event portal. We're going to do some code generation and some integration with Solace and Kafka live. We're going to be doing a live demo, which is always a little bit scary. So be sure to register for that. It should be a very interesting conference. Obviously, Kafka very well known in the event-driven space, dealing with kind of data pipelines and log shipping. We're happy to be there as a speaker. And I think are we a sponsor? I have no idea.
Yeah,
we are.
Yeah, we're a gold sponsor.
We're a gold sponsor. Awesome. Yeah. See, we're friends, actually. We're actually friends with Kafka. Okay, so, hey, no questions on the chat yet. I'm going to put up a little reminder here saying, hey, ask us a question. Yeah, you want some swag? Ask some questions.
Ari just joined. Hi, Ari.
Hey. Hi, Ari. Yeah, so Ari is the man who's going to be doing all of these Kafka Solace demos in a couple weeks. Come watch us at the Kafka Summit. Come say hello there. We'll be happy to have you to our booth and show you some stuff. Yes, see you there for sure. All right. Hey, so Steve, while we're waiting for a question, anything that you want to talk about before we kind of kick off and start just talking about random things? Anything that you've had come up recently with a customer or something? Something?
Not that I can think of.
All right.
No.
Okay, I have one.
It may come to mind later.
Okay, I have one. So yeah, already saying hi to Steve as well. And hey, Modem. Hey, hello. Welcome to the live stream. Thanks for joining. Thanks for tuning in on LinkedIn there. So I had a customer asking about the difference between kind of a blocking receive and an asynchronous receive, and when to use each, and what are the advantages and what are the benefits, and stuff like that. And so I went kind of digging through our documentation trying to find something, and it wasn't that obvious exactly where to look. So let me just, I'm going to pull up my whiteboard here while I'm just chatting away. Let me just stop sharing and then share my whiteboard screen. Share this one. Yeah, all right. You can see that, I hope?
Yeah.
All right. So let's say we have our Solace broker here, and we have, maybe a queue that has some messages in it. It doesn't have to be a queue. It could be using direct messaging, so just subscribing. And inside this is my application over here. It'll have the Solace API as part of that. So Solace API, or maybe, we support other protocols like AMQP, MQTT. You could be using one of their protocols. But essentially, inside this code somewhere, we're going to be connecting to this queue or topic or something and pulling data off of it, right? So you have two choices for kind of how to do that. There's sync and async, right? Sync, the way that you do that typically is you kind of call a receive method. I can't type. Receive, right? Where you basically say, hey, queue, or hey, topic, or hey, consumer, receive, try and receive the message, where you basically, your thread itself is trying to pull data off that object. In Solace, there's kind of pre-caching, and same with Kafka. Like in Kafka API, you pull from the consumer, but it actually pre-fetched it into the API space. So you're not actually going to the broker directly, but you're saying, okay, give me the next message. Versus async, the way you're going to do this is with a callback. And so almost all of the Solace APIs, that I know, they all support an asynchronous callback, right? And which kind of makes your code be event-driven. Solace is always talking about being, event-driven. That is our big branding, be event-driven. In terms of communication in your application, that usually means use publish, subscribe. Don't have a polling type of architecture where you have a database at the center of your architecture where you're kind of reading from a stateful database. Basically, as events occur, they're just sent out into the mesh. But from an application perspective, if you want to be event-driven, you're going to be using callbacks. And so if we go and take a quick look at, let's go to docs while I'm just rambling on here. And Steve, feel free to interject here at any moment with some brilliant ideas. But yeah, I'm just going to pull up the Solace developer guide here and take a quick look at receiving. I think this is somewhere.
Yeah, essentially, the first way, the synchronous way, is you tell the API when you want a message.
Yeah.
And you only get messages as quickly as you can call the API. So it's nice and safe.
Yeah.
But with the other way, you have not much control over when the messages arrive. So they could arrive faster than you can process them. Because asynchronously means that whenever the messages are available, they'll get thrown to you, the application. That's
right. Now, so it basically means it's also like, which thread is this occurring on, right? So in synchronous mode, you're going to be receiving a message on the thread that you call it from, right? So inside your app, you might have, your main thread. And if you call receive from here, you're going to get the message on that thread. And then you can, you typically have it in a loop. You do some looping, and you would pull data from that connection as fast as you can. You're right that, you can pull data as fast as you want, so that if you need to do some update or some processing, you essentially just stop calling receive temporarily. But of course, data could still be arriving faster than you're pulling it in, right? So somewhere there's going to be some buffering, somewhere there's going to be some, hopefully, it's getting stored safely without having to be thrown away. But yeah, the callback method, this is asynchronous. And so I think in Solace world, get message consumer, you get a message listener. These aren't links. I think it's called on receive or on message. On message.
On message. I think it's
on message.
Yeah, I think it's
that might be the JMS term. So you basically specify an interface, a method that runs, and this is what the API calls whenever a message comes in there, right? So this is running on the API thread, and it is basically receiving a message saying, "Yay, we've got a message. A message has come in from the broker." And this way, your main thread doesn't have to sit there kind of looping, right? Your main thread can just go to sleep and wait until it receives some kind of quit notification or something to say, all right, my application is done. And that way, all of the messages that appear in your application are actually going to be inside, essentially on message is running inside an API thread. Maybe I should color these blue and red or something. Anyway, that's a little bit messy, but that's essentially the big difference, right? Is the synchronous receive call is you're very much in control. You can call it from the thread that you're in and process them at the speed at which you call them, versus the on message or on receive, I forget, callback method could actually simplify your code. Essentially it just says run this message handler code when a message arrives. You don't have to worry about looping. You just get a method that gets called when a message arrives. Very event-driven programming style, where you're not blocking and waiting in your main thread. So, yeah, that's about it. It really comes down to like, what do you, the application creator, want to do, right? It's you have both options, so that's kind of nice. A lot of things you don't need the complexity of a writing code that's asynchronous is actually a little bit simpler. So if you are a JCSMP person, we actually have some new GitHub samples that we're working on. So this is, we have a brand new Java API that we're actually still in EA. It's coming out very, very soon. We're working on some samples for that. But our existing JCSMP samples, JCSMP API, which is not getting deprecated, it's not going away, but it is a bit old, battle tested, I like to say. We have some new samples for that. And inside there, we have examples of both synchronous and asynchronous receivers, right? So if you take a look at, for example, direct subscriber here, this is kind of your basic, just direct, non-persistent style of receiver. You can see that here is, it's on receive, Steve. Can you read that? There it is. So that's a Solace term. I think it's JMS is on message. But same, right?
Yeah,
so
it depends on the API. Yeah.
That's right. Yeah. So this is my method that says whenever a message arrives from the broker, run this method. As you can see, it doesn't really do anything. It just adds one to the counter, and that's about it, right? So, but yeah, we have other samples that are blocking. I think this one, my guaranteed processor one. You can see down here.
You're still sharing your white.
Oh, I'm on the wrong one. Oh, sorry. Thanks for that. Sorry about that, everybody. There we go. Yeah, so what I was just showing a second ago was direct subscriber down here. So this is all GitHub. This is github.com/Solace samples. We're looking at the JCSMP, our Java API samples right now. And just this is an example of, this is a consumer application, a subscriber, and this is where it's defining the kind of the callback, the on receive, and this is the method that gets run when it receives a message. Very simple, not doing any processing. Typically you would, draw this to the screen or update a database, or you do something with this message, right? But right now we're just counting it. It just is basically a little performance code here. But if we wanted to look,
actually, you shouldn't spend a lot of time doing stuff in that callback.
That's right. The main thing is because, the callback thread you don't own, right? As an application, the callback thread that the API, the Solace API is calling your callback method, it's the API thread. And it probably has other stuff to do. It doesn't want to sit there being blocked in your thread waiting for something to happen. In Java, it's a little bit safer. There are kind of there's mechanisms built into the API that even if you did block it up for a little while, it's not going to be the end of the world. But our C API and .NET, which it's based on, there is only one thread. There's only one context thread, and you can get into a situation where, yeah, if you block the main thread, you can get into trouble there. So it's quite well documented throughout, like all of the C and .NET documentation. Yeah, if you're in a callback thread, do not block for very long. Do not take a long time to process. Yeah, so this is an example of a synchronous receive, right? So this is instead of a queue receiver where I'm just calling receive, saying give me a every 1,000 every second, I kind of pop out just to see if I've received a quit message. And this is my, it's a little bit different logic, is just have your main loop receiving from a queue or from a consumer versus having the asynchronous callback. So different ways to slice and dice. It depends on your use case, which one you want to do. So yeah, that's kind of what that guy was asking about, and hopefully that helps to somebody. Okay, let me move this out of the way here. All right. Hey, Nitin. Hello. Hi, you got a question out there? Tell us where you're joining from. Say hi if you have a question for Steve or I. Yeah, we'd be happy to answer it. We're just gonna talk. But if people want to have something to say, that'd be awesome. Okay, Steve, do you wanna pick one, or do you want me to?
Just pick one. Yeah.
All right. Well, yeah. Let's take a look at this. Maybe even if we can't answer it, maybe we can kind of discuss what's going on here. So this particular member was saying that they seem to be getting their application disconnecting. They're getting a channel closed on their API logs, and it's closing on its own. When I run this locally on my development machine, the connection remains open and is not closing on its own. So basically, he's getting it's closing automatically. He's not sure why. And it's using Kubernetes and Spring. So that's a bit interesting. Typically, in the Solace world, you do not want your applications to be connecting and disconnecting and connecting and disconnecting. It's not like REST where each individual, call, post, or whatever is kind of atomic or stateless. Typically, yeah, you would connect to a broker and you stay online for the duration of your, forever, essentially, until your app is completely done, right? So let's see here. Let's see what people said. Caching connection factory is usually the culprit, correct? Yeah, if in Spring world, you want to use a caching connection factory, which means that every time it tries to send a message, it's going to reuse an existing connection rather than creating a new one. That's a really good point. Using Spring, blah, blah, blah. Okay, yes. Spring boot. Closing the connection. Right, so how would you go about doing this? Mark's actually tagged me. I'm gonna have to go in back and connect on it. So things that can cause an application to disconnect. Things in the Solace world. Obviously, Kubernetes is complicated, and there might be firewalls or load balancers or watchdog processes in there that I don't really know. Have you ever? I don't know much about Kubernetes, Steve. Like, have you?
Yeah. Kubernetes. Okay, Kubernetes basically is another container management environment where you can run your software.
Yeah.
So it handles a lot of the management side of things for you. Like if your application stops or crashes or something, it'll spin it up again, possibly on another node. So it has all that high availability, fault tolerance, all that built in. You can also makes it easy to run a certain number of instances. Like you can say, I want 10 instances, and it'll just spin up 10. It'll keep them running. Even if some crash, it'll spin up another one just to make sure there's that number of instances running, and a lot of nice things. But it is complicated to set up at first.
It is, and it's yeah. Sorry. keep going.
And also, Kubernetes is not mature yet. It's still evolving quite fast. So things are not, how should I say, they're not stable yet. Even though you might know it works a certain way today, next month it could work slightly differently. And new features are coming out all the time. So it's still a rapidly evolving technology.
It's great for running, it's great for running Docker containers. It's great for running little small stateless apps, microservices. People do try to run Solace brokers inside Kubernetes, which I do not agree with. I think, infrastructure type applications, large scale databases, they're not native to Kubernetes. They're not built for doing that, right? So Kubernetes seems to be more apps oriented. As you said, you can scale up, scale down, load balance.
Yeah, stateless stuff.
It's stateless. Yeah, it's great for stateless. You can run you can run stateful apps in Kubernetes. It's just it's more geared for stateful stuff. And Solace brokers as infrastructure, those are very stateful, and so they don't necessarily, in my opinion, belong in Kubernetes. Yeah, that's not the point. The point is this particular thing. He's saying that he is running the broker outside, so it's not the broker that's running in Kubernetes; it's his app.
Okay, right. So the broker is outside Kubernetes.
Right.
It's the app that's inside.
So there's a Spring app running inside Kubernetes. Mark is asking if there's a load balancer. That is a great question. Some kind of flapping happening because Solace uses Solace's protocol, or Spring Boot or Solace native protocol. It's not like a WebSocket connection. Sometimes maybe if a binary protocol, something Kubernetes doesn't understand, maybe it's doing something that it's not quite sure. Two things that came to mind in terms of I don't know exactly what's wrong, but in terms of troubleshooting, one is exactly this one. So on the broker side, there are logs that the broker emits. So there's API logs on the API side as well as at the broker side. You can do show log events. This would be inside the CLI. Or let me bring up a terminal here. A lot of people run Solace containers as Docker, right? Do I have so can you read that okay, Steve?
Yeah.
So Docker, so you can see my container here is called Solace 99. You can log into CLI. A lot of people, administer their Solace broker by going to, localhost :8080. This is the PubSub Plus manager, the GUI. But we also have CLI. But we also, there's basically you can log into the actual container itself and look at the logs kind of exactly inside the container. So I'm going to say I want to use Solace 99 container. You just say bash. And it pops you straight into inside the container. And then under jail logs, you'll see that there are some logs. And I can take a look at my event log. So this is, if you actually want to look at the actual log files, here's a quick trick. You can access it through the Docker container by executing bash, or if you're running the software, the machine image, like the OVA, I think you access it via Solace CTL. You say Solace CTL shell, and you can log into the shell. And that's how you can access it. So yeah, checking the broker logs is really good. The other suggestion I had, so you'll notice up at the top here, this com.solacesystems.jcsmp protocol, this is an API log. And I'm pretty sure this is probably, the default would be either info or warn. Now, the Solace APIs use Jakarta common loggings or Apache common loggings. So if you're hooking this up to log4j, there's bridges available for that. You should see if you can turn on debug logging in your application. That would really tell you what if there's any reason that the API is disconnected. So essentially what we're trying to do is figure out, is the broker terminating the connection? Is the API terminating the connection? Or is something in the middle terminating the connection? Those are kind of the three options I guess we have, right? If the broker is doing it, it could be for a keep alive. If the API is doing it, again, it could be maybe for a keep alive, like it's not able to connect to the broker, or it's something in the middle that is just bouncing the connection for some reason. So that would be my my suggestions. Crank up the logging, see what else you can find.
Yeah, crank up the API log, because
Yeah.
when you look at this issue, the only difference is when the application is running outside Kubernetes, it works. When the application is running inside Kubernetes, it doesn't work. So the difference is the Kubernetes. So
okay.
I don't think the issue is on the broker side, because nothing changed there. So the issue is most likely to be on the application side, or somewhere between the application and the broker, because that's the only thing that's changed.
So okay, so I didn't read it that carefully. So you're saying that, yeah, so when they run their app outside of Kubernetes, it works fine. But when they run their app inside Kubernetes, okay, yeah. So, yeah.
So nothing's changed on the broker side.
That's interesting. So that definitely sounds like something inside Kubernetes is causing that connection to kind of break or something, right?
Yeah.
Just as an example, like, yeah, talking about debug level logging, this is something that a lot of Solace users don't actually know about, is all of our API logs have, or all of our APIs have quite detailed logging built into them. But you have to enable, just like most applications, you have to enable debug logging to actually be able to see it. If I was to run my kind of basic hello world application, null pointer exception, this is my, I'm in my stage directory. I've started messing around with my samples, and now it's going to be pointing out weird things at me. This should still work. So pardon, let's just run a different one. How about direct publisher? There we go. And I say localhost, default, just to show you what kind of logging is available. So there we go. So with default kind of info level logging, you can see that I say connecting to host, connected, and disconnected. Not very verbose, right? Let's quickly edit my log4j property file here to like crank it up to debug logging. Debug. All right, watch this. Let's see how much logging there is this time. Yeah.
Yeah.
So obviously a lot more information is available when you crank up the debug level log. Not something you probably want to run in production. That's probably a little bit too much, but very, very useful when trying to figure out maybe something that's wrong on the API side. So hopefully users out there have their logging configuration externalized, as I do here in my my log4j configuration file, and you can just kind of change the logging level on the fly there. So yes. All right, more people tuning in. Hello. Welcome to the Solace Office Hours live stream chat. Happy to answer questions. People, yeah, no questions today. People just saying hi, which is really nice. But I want some questions from people, please. That'd be really great.
Yeah. Any if you're using Solace, any challenges, any questions you want to ask about?
Any use cases?
Or use case, interesting use cases.
Someone giving tips on Solace's. So yeah, Solace, we have a couple different examinations. Event-driven practitioner, architecture exams. Actually, my colleague Giri and I were working on a Solace developer exam questionnaire. Yeah, a bunch of different stuff. So if you want some tips on how to pass these things, check that out. I don't know if we should be making that too public. Maybe it's. I wonder how detailed this guy goes. But yeah, there's. Is it working? Come on, Aaron. Go in there. Yeah, so if you want some tips and tricks on how to pass your Solace certification EDA practitioner exam, go and check that out. Let's see here. What else? CLI scripts. All right, yes, this one. So in terms of doing DevOps type stuff, right? So people often ask, hey, how can I automate some stuff on the broker? Maybe I want to do configuration. Maybe I want to do some testing. In this particular case, this user, RG Desoju, is talking about CLI scripting. This is one of 3 ways of interacting with the broker for admin type stuff: the GUI, the SEMP management API, and our command line interface. And you can actually script the CLI. And this is how a lot of admins in the old days used to configure Solace brokers using CLI scripts. not necessarily our best practice anymore, is it, Steve? It's not something that we I mean, we can do. You can still use it, but you know, we tend to recommend people look at SEMP.
Yeah, because it's REST based and it's more. It fits more into the new CI/CD tool set. You know,
Right.
a lot of people are going continuous integration, continuous delivery tools like Ansible, and they love REST, all these tools, and SEMP is REST. So I guess it's more popular now to use SEMP to configure the broker. But there's nothing wrong with CLI. CLI is still very useful.
CLI is great. I just, you know, just in terms of scripting with it, it's a little bit, you know, so if people have never seen CLI before, again, they can just, if they're using Docker, they can just execute CLI and they'll pop inside their broker. And then they can say things like show Q star, show, you can do show commands or show message VPN star, detail. It's great. I love CLI. It's really fast. You know, there's built-in help. You can use tab to do auto completion of things. Hit tab and it kind of auto completes things. CLI is great, and yeah, you can script it. But it's, you know, it's an SSH. It's an interactive terminal. Back in the old days, we had to use things like expect to actually do scripting, like automated scripting sometimes. So yeah, REST is the more modern way of doing things, and you should be able to, yeah, if you just Google Solace SEMP. Solace SEMP. Yeah. Here's our API reference. Fully documented Open API Swagger style reference guide here that should tell you everything how to do, right? So you want to create a queue, you want to monitor a queue, you want to create a username or change some authorization, whatever. All of that is available, you know, get, post, delete, patch, all that kind of stuff. So much easier way of, more modern way of doing things. But yeah, you can still use CLI. I think that's
CLI is good if you're doing interactive stuff. If you're sitting in front of the keyboard and you just want to look at things or change something, CLI is great. SEMP is good for scripting or automating configuration management.
That's right. That's right. I mean, so I had a conversation with some of our folks from headquarters, R&D in Canada, and they were talking about some of the automated processes around testing their own APIs. And the older APIs, yeah, that it uses a CLI script to configure a Solace broker with a bunch of queues and a bunch of usernames, and then they run their testing. And the new Solace APIs that they're developing, specifically Python and the new Java API, all of the testing framework, all of it is using SEMP v2. All of it is fully RESTful. It's using Docker containers, and basically all of each individual API unit test, you know, has a broker spun up. It configures it with SEMP, and it kind of configures it the way it wants. It runs its test, and then it tears it all down and starts the next one. So even internally at Solace, yeah, we're using SEMP as our new fangled way of doing CI/CD unit testing, integration testing for our own APIs. So that's definitely what we would suggest there. So
right, we've got a question on the chat.
Oh yeah.
Madhu asks, do we have any best practices for setting up Solace? Well, yes. In fact, most of our documentation can be Googled. So if you Google Solace best practices, the first link that comes up are the best practices.
Best practices for what though? Oh, for everything.
Yeah. So it's broken down into parts.
I've never seen this page. This is a new page, I guess. All right, topic architect, very useful when you're building your distributed apps. DMR for building your event mesh. Multi-site connectivity, yeah. Scaling, replay. What about micro gateway? So these are all best practices once you have your stuff configured, but like in terms of actual setup Solace. So like setting up Solace, you know, like in the cloud, setting up Solace on-prem for machine images. Well, I mean, there's lots of different ways to, you know, to set up Solace. And over on the left here, you can kind of get at least some links on the different styles of software broker that we have. Yeah, I guess a little bit more details. But yeah, if you have something specific around setting up Solace, best practice. If you are in production, you will want to be setting up your Solace broker as an HA in an HA configuration, right? So you'll have an active, a standby, and then if it's a software edition, yeah, you'll have a third monitor node, which detects. That's how you kind of set up your triple for quorum, for preventing split brain. If you are deploying this in the cloud, you would typically want to run each of these 3 nodes in different AZs, different availability zones, so that if one AZ crashed, the other one can take over. Best practices. I don't know what else. Naming conventions for your message VPNs should be, you should standardize things. Port definitions. I don't know. Other things to consider. Each Solace broker can support multiple what we call message VPNs, which are kind of a virtual container on the actual broker itself. It's how we do multi-tenancy. For the software broker, you have a choice of running larger brokers with multiple message VPNs or smaller brokers with one message VPN per. Pros and cons. We could talk about this for quite some time. So if you have it, if you have a more detailed, we got a thanks. Oh, that's nice. Hey, you're welcome. If you have a more detailed question and you want to just follow up with us, post it on the Solace community. That's a great place to get a little bit more detail, and a lot of very experienced Solace engineers are hanging out there and can help guide you in terms of the best way to set things up. Solace community. One thing I want to point to, I think, I thought it was somewhere under here. Setting up container images. It basically walks you through, like, for example, if you're using Docker, blah, 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 setting all this stuff. Down towards the bottom here, this gets into the more kind of production quality things, right? Like how to set up externalize your volumes to make sure that you can do upgrades and stuff like that. Container logging so that it helps you troubleshoot things more easily. Other things like that. There are generally, if you read the docs, there's a lot of docs, but they typically go through quite a bit of details on how to configure this stuff. So thanks for the question. And yeah, if you have more detailed ones, come and ask it on the community or ask it right now. Do you have any Docker image to run Solace? Yes, we do.
Oh, yes, on your screen now, there are some Docker instructions for different platforms.
Yep, so multiple ways of pulling this down. We have our downloads page. You can actually just download the Docker container from here. If you just Google Solace getting started, I'm pretty sure. Pretty sure you can just click on this. Software or cloud software. Yeah, here we go. Docker, and it is a single, there you go. A single command will go and do a Docker pull and run it on your local machine. So if you have Docker running locally, one command to do that. So boom. I wonder if I can actually put this into the chat.
Yep.
There you go.
Yeah, there's one thing, if you're on a Mac, then you'll find it with the latest versions of the Mac OS. They've reserved port 55555, so you just have to remap that port to something else. So Apple has reserved 55555.
That's right. I believe we have a thread on it. Yeah, we do.
Yeah, we just have to remap that single port and it'll work just like before.
So, right. So port 55555 has been the Solace native messaging port since Solace was created way back when. Apple has now usurped it. So at least with the Docker container, we have this ability to easily remap ports, right? So if you're familiar with Docker, this should make sense to you. But if you're not, these are essentially what port internally and then what port externally you're mapping. This is essentially a bit of wiring, right? So this is saying I want port 555 in my Docker container to talk to be exposed to port 55555 on my host that I'm running this on. So I guess the if you just tweak this to 555 something else.
Yeah, anything. Yeah, something else it'll work. Yeah.
They must actually say it here somewhere.
55666 will work. 55556.
Right. 55566. Anyway, just choose any other port. But yeah, if you're on a Mac, if you're running your Docker container on a Mac, that is one thing to keep in mind. I've seen this fail on my Windows machine once or twice, and I added some firewall rules to my my NAT service, whatever. I did some Googling. But then I wanted to verify that my fix actually worked, so I undid the changes, and now it hasn't happened since. So I'm not exactly sure why, but on Windows, I had this happen once or twice as well, that it ran into problems specifically on 55555, that Windows had just randomly reserved this port. So if you run into this on Windows, if I ever run into it again, I'm going to make a posting on the Solace community, but it seems to have been resolved. So I'm going to kind of say it for now. All right. What else? We got some other questions here. Suresh. All right, more questions from Suresh. Do you support the images for future patches?
I think this is for Docker. Yeah. Because Suresh was asking about Docker images earlier. So
correct. Yeah. Yes, Docker. So support the images for future patches. So I mean, as Solace discovers, issues or bugs, or as they upgrade add new features, we're constantly rolling out new images. We support, Solace supports the GA software releases for it's only like 7 years or something, isn't it, Steve? If you're paying support, I think we support things going back. Is it that long? Maybe it's 3 years. I'm not sure.
3 years, yeah, about 3 years, I think.
I don't know. Solace.com/support. Solace.com/support, I'm pretty sure talks about some of how long things last for. But anyway, the question is, yes, Solace support. If you buy support with Solace, all of our released software brokers, be they Docker containers or machine images, they're all supported for several years. Upgrades are free. When you buy Solace support, basically you get access to all of the APIs, all of the images, all of the documentation for going back for some time. This is all around response time. It's a 12-month plan. Here we go.
There it is. Support duration. Yeah.
Blah 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 blah. So yeah, Suresh, if you want to go and check out solace.com/support, it might answer. Here we go. 3 years are supported for 3 years from the first date of general availability. So that is how long we support our Docker images. So for production environment. Hopefully that answers your questions. Thanks. Okay. Hey, we got a few more questions here. Nitin, hi all. How can I get logs from Solace to track end-to-end messages from publisher API to Solace? That's a good question. Track and trace, end-to-end. Yes. I can talk about it. Steve, do you want to talk about it, or do you want me to talk about it?
You can talk about it. Yeah.
Okay. So basically, Solace, since its inception, since its heyday, it's been designed as a high performance broker. Like we originally started out as hardware. Solace does not have tracking today on a message by message basis, simply because our hardware platform can do millions of messages per second. And there's no logging framework in the world that can actually keep up with that. We did have customers that wanted that kind of traceability, and they had to end up using things like network switch port mirroring, and they would have plugins to like Coreville and all sorts of crazy high-tech, high-speed monitoring stuff. But we are working on something today in the future to allow track and trace for messages. And so this would be hooking up to OpenTelemetry, which is an open source initiative that is meant for basically tracking events, messages as they go through your system. And in the Solace world, yeah, it would allow you to hook up an OpenTelemetry consumer, compatible consumer that would be able to listen to essentially message lifetime events as it moves through the broker. So as of today, as of right now, you can instrument the Solace API, the publisher and the sender, so you can actually see when you get a message. In terms of the within the broker, you can query who is subscribed to what topic. There are events that are generated when a client adds a subscription, so you can kind of monitor who is subscribed to what. But on a message by message basis, in and out, we don't have that level of granularity today. And that's something that we're building into the product right now. So it kind of depends on what exactly you need, how detailed do you need. But if you're very much like, I want to know when this message arrived at the broker, which queues it went into, when it left those queues, when the acknowledgement for those messages came back to the queues, when it was deleted from the queues, all of those, that is being built. It's being scoped out by R&D right now. I don't have an ETA on it. It's a pretty large feature, simply because it's very deep inside the broker internals. So it's probably going to be a while, maybe end of the year. I don't know. I actually haven't heard any updates on when I know it's happening. I know that it's happening. So yeah, that's what I have to say about that. So I don't know, Steve, do you have anything to add or?
No, I think that's a good answer. Yeah. So it's something that a lot of people have been asking for. It's just that there was no logging framework that was capable of running at like tens of millions of messages per second. Yeah. But I think the world is changing now. More people want track and trace, and so we're going to build this into our product. And like Aaron said, so I think Aaron's answer was pretty good. We are building this into our product. It's just we don't have an ETA for it at the moment.
The number one use case for this we seem to be is when you have a dedicated team, a middleware team or an operations team that is handling your broker, and then you have application teams that are distributed because we're talking event-driven architecture. You're talking distributed applications. You get into this he said she said thing with regards to like kind of non-repudiation. I sent a message. Well, I never received that message. Okay, well, prove it. And so oftentimes the ops team in the middle is caught trying to verify or show that, yes, we actually did send this message. There are statistics and there's counters and there's things that, if you're watching the broker stats in real time, you can see a message come in and go out. You can add timestamps to your message as an application, and you can verify the timestamps on the receiver side. So there are lots of things you can do today in the broker to help prove things. But yeah, that's very specific message by message tracking capability is something that we don't have, and we're building it. So that is my long-winded explanation. So Nitin, hopefully that helps. If you have more questions on it, come find us on Solace Community, ask there, and we will answer. We can get into it more. But don't ask me when it's coming out, because I don't know. At some point. Giri has something to say here. As with standard cloud instance provisioning, in AWS GCP, does Solace support instances of different types like small, medium, large, etc.? So for the software broker for cloud, how do you interpret that, Steve? As with the standard cloud,
I think Giri's asking about self-manage, about running your own Solace brokers on the cloud, and whether you can have different types. So I can take this one. Yes. Yeah, sure. So the Solace broker has what we call different scaling tiers, and a scaling tier involves a number of CPUs, some amount of memory, and the larger the scaling tier, the more messages it can handle per second. So I think Aaron's bringing up on the page now on the screen. So depending on your scaling tier, you can choose what instance type you want to use. So for example, I think the smallest scaling tier for production is 2 CPU, 4 gig of RAM. So that will be some instance type in AWS. That will map to some instance type in AWS. So yes, so we do support. I think our biggest scaling tier is 8 CPU.
Yeah, here we go.
64 gig of RAM or something like that, or
That's
18
right.
C. Yeah.
So yeah, I found the table. Can you read that okay?
Yeah.
Okay. So the biggest one, I think, is this for Docker? So plus or minus, right? Our largest single node can support 200,000 concurrent connections. It requires, you need at least 2 to run the lowest, and then plus 10, so 12 CPUs.
12
This is a beefy
CPU,
machine.
Yeah.
50 gigs of RAM, more or less.
Yeah.
Blah, 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 blah. So that's a massive, like that would be like an IoT scale connected cars kind of broker, like 200,000 connections. That's bonkers. You're not going to typically run that, right? So you have small, the default is 100 connections. I think you get like 1,000 subscriptions and 100 queues. And basically there's system limits set up for each one of these things. And as you move to the next scaling tier, I think are they called connection scaling tiers still? I forget.
Yeah.
But scaling tier.
Yeah, scaling. Connected. The basic metric is number of connections.
Yes, and everything kind of scales with that, right? Number of queues, number of outstanding messages that are allowed, number of flows, all that kind of stuff kind of scales up, and you have to essentially just throw more memory and more CPUs at it. So configure your Docker container or your VM appropriately, and then you can if you try to, essentially this requires a restart, right? So if you want to go from one scaling tier to another, I'm pretty sure it's a CLI command.
Yeah, it's a CLI command. Yeah, and then a restart. Yeah.
Show system. Yeah, so scaling. So if I go enable config system, it's somewhere in here, right? Scaling. Yeah, so here is where I can set the maximum number of connections, and here are my options. And if you try to set this to a number that's higher than you've given it enough RAM for or enough CPUs, I'm pretty sure when it reboots, it just complains. It says it can't do it or something, right?
Yeah, even if it can do it, it's not supported because you're running too small. We don't support it. Even if it can start, but most of the time it won't even start. It'll complain it doesn't have enough CPU or RAM.
So in that case, you just have to reset it back to a lower level. So
yeah, or give it more memory or CPU.
That's right. Yeah. So Gary, if you're running your own software container in the cloud, just pick the right EC2 instance or Google, whatever it's called, compute node instance, size it for the scaling tier that you want. Most use cases, I would say, Steve, we're probably in the 1,000 or 10,000 range, right? That's probably your typical broker. Maybe 100 for small little apps, but this 100,000, 200,000, we only see that for kind of IoT type use cases, right? So
and if you just want to run it for development purposes, then a T2 or T3 type AWS instance type is perfectly okay. But if you're doing something specific, like if you want high network bandwidth or something, then you go for the high bandwidth instances. If you want very fast guaranteed messaging, then you go for the very high I/O bandwidth instances and very fast disks attached to it.
That's a really good point. Something that people don't usually think about when they think about deploying Solace or, again, infrastructure networking type applications into the cloud. Cloud is made very much for compute and memory. It's really good at that, maybe storage. But Solace as a technology requires network and fast disk. Those are the two things that make your broker run fast, because Solace is essentially your network, right? And so if you want any reasonable amount of performance, you have to make sure that you're choosing instant types that have the disk is an SSD. It has a high number of IOPS if you're going to be doing guaranteed messaging. If you are going to be supporting a large number of connections that require lowish latency, you'll probably need some kind of enhanced networking package. And so often, even if your connection requirements are fairly low, you might need to bump up the instance type just to get that fast disk and that fast network available to you. So as with anything, test, do some scaling testing. As Solace technology people, if you're saying how fast does it run, we can tell you how fast it runs in our lab with our specific setup, but to test it on your setup or with that particular node and that particular setup, you just need to deploy it and do some testing. And we have lots of tooling available to do load testing. SDK perf is our favorite command line test tool for doing load testing. Check that out. And I think that's all I have to say about that. SDK perf. Can you just Google that? I wonder. Yeah, you can. So and for also, anybody,
yeah. Yes, and we do publish performance numbers on AWS. So we say what instance type we're running on, what disk type we're running on, and things like that. And we publish. It's public. The results are published. You can reproduce this if you want.
Yep.
So if you if you Google for Solace performance, the first link that you come up to is the official performance results.
I'm showing it right now.
Yeah. Yeah.
So we use M5X large for our testing there, and kind of some of the other things that we test, and that's our best numbers. That's the best thing that we can do. So if you want a baseline for just how fast Solace can run in AWS, cranked up to the max. We talk about it. Look at that. Good stuff.
Yeah, so these are not the maximum. I've managed to exceed these numbers with bigger instance types or faster disks or bigger disks. So this is the representation of what we can do with that M5X large. You can certainly go beyond these numbers if you have better instances.
Oh, okay. Most companies produce the highest numbers that they can. Like we should get M5XX large or something, whatever the biggest is. I don't know.
And also, AWS constantly upgrades their instances. So an M5X large today is not the same as an M5X large last year. Chances are the ones now are faster than the ones before. And it could be an M6 next time. So the number is the generation. So an M5 is generally faster than an M4 and so on. So what are we up to now? We're still up to M5. Okay. They haven't come up with the M6s yet. Or M5A, I think, are faster.
M4, M5. Very cool. So basically they keep moving the goalposts. And so I guess we as Solace people, we need to keep testing and trying different things, right? So this is the enhanced network. This is the thing that I was talking about, where if you have like a really big fan out, for example, or a really high message rate, most people, when they're doing cloud computing, they're not using huge amounts of network bandwidth, right? They're using compute. But Solace needs more bandwidth. So this is where, you got to make sure that you have this kind of stuff enabled. So great question, Gary. Thanks, thumbs up. All right, very good. And Nitin, thanks. All right, thanks for that. Hey, Steve, we're at the top of the hour. It's any closing? That was a good session. We had some good questions there, I thought.
Yeah, it was very good questions.
Yeah, thanks, Nitin. Thanks, Suresh. Suresh had a couple questions there. Happy to answer questions. Come find us on Solace Community. We hang out there. We answer questions as much as we can. We don't know the answer to everything, but we can always find people that know things more than we do. I think that's it. So check out, sign up from some Solace events. You'll find out when we're talking next. Come find us at the Solace Kafka Summit. The Kafka Summit APAC in 2 weeks. Come watch our demo on how we integrate with Solace with Kafka. It's going to be pretty good. And thanks, Steve, for joining. It's great to have you here. Thanks for taking the time to do this. All right, so I'm going to play the little outro here. And thanks, everybody, for watching. And we're going to see you. We'll see you next time, right?
Yeah.
All right.
All right.
Bye.
See ya.